Hey guys, so we're going to get started with lesson 1.4 today. We're going to be talking about perimeter and area in a coordinate plane. We do have some vocabulary to get started with first behind me, so let's start there. Alright, so a polygon is a closed plane figure formed by three or more line segments called sides. Okay, we're all familiar with different polygons: triangle, a quadrilateral, pentagon, hexagon, octagon, and so on and so forth. All right, a side. A side is a segment that forms a polygon. Segments that form a polygon. All right, the vertex. Okay, by definition, the vertex is the point where a graph changes direction. When we're talking about a polygon, if we just look at this pentagon down here, all right, the corners, right, where the segments intersect, the segments meet, those are your vertices. N-gon, a polygon with n sides. So there are certain polygons that we know the names of, that we learn the names of, like a three-sided polygon is a triangle, right? But we could also call it a three-gon. A five-sided polygon is a pentagon, right? But instead of a pentagon, you could call it a five-gon, and so on and so forth, all right? Next, we have convex versus concave, which I know you guys are familiar with as well. By definition, convex is a polygon with all its interior angles less than 180 degrees. A concave polygon is a polygon with one or more interior angles greater than 180 degrees. The other way you can determine convex versus concave is if you extend all the sides of the polygon. All right, all of the sides here, if you were to extend them, none of the sides enter the interior space of the polygon. For this one, as I extend the side, so far so good, but as I extend this next side, see how it enters into the interior space of the polygon? Therefore, it is concave instead of convex, okay? All right, so that is most of our terminology. So let me erase the board to get set up for the next thing. Okay, so next we're going to start talking about perimeter, area, and of different shapes. Okay, most of this, again, you already know. I'm not going to write it formally in your notes. I'll just kind of quickly go through it. When we talk about the perimeter of a shape, we're talking about the sum of the lengths of the outside of the figure. So we all know we can just add up all the outside segments together, and that'll give us our perimeter. Our units are always linear measures, something like centimeters, meters, inches, feet. Okay, the area of a polygon is the number of square units in the enclosed part, so on the inside. And our units are always squared. So it would be like centimeters squared, inches squared, feet squared, and so on and so forth. The area addition postulate, it's kind of similar to the segment addition postulate, where you take two smaller segments, add them together to get a large segment. If you have an irregular shape, something like that there. Okay, you guys know how to do this. You've done it before. You're going to break it up into shapes that you can find the area of. So for that one there, I broke it up into three different rectangles, found the area of each rectangle, added them together. That's called the area addition postulate. Okay, circle. We talked about circles in the last lesson. We found the equation of a circle. We name a circle by its center point. So if the center has an A next to it, we call it circle A. We leave, or if it says to leave your answer in terms of pi, that means you leave the pi symbol and you don't multiply by 3.14, okay? And then some common area formulas and perimeter formulas. If we're finding the perimeter of a square, you can just take one side and multiply it by 4, right? If you're finding the area of a square, you take a side and square it, side squared, or length times width if you want to think of it that way. For a triangle, you add up 3 sides of the triangle. If you want to find the area of a square, it's 1/2 base times height. Again, a formula you're familiar with. A rectangle, add up all the sides for your rectangle's perimeter, or you could take the base and multiply by 2, the width multiply by 2, and add them together. And then the area formula is base times height, or length times width. Okay, and then finally for a circle, the circumference of a circle is pi times diameter, or 2 pi r, depending on which one you are more familiar with. And then the area formula is pi r squared. Okay, so that's just a quick review of some area formulas. All right, so let's get into some examples. And pick and choose which ones I want. Okay. So for this first example, I'm not going to write the entire word problem out. I'll just read it to you and then we'll draw it out together. Okay, it says the botany club members are designing a rectangular square garden for a courtyard for their school. They plan on placing edging on the outside of the path. The garden will be 22 feet by 16 feet and the path around it will be 4 feet wide. Okay, so let's draw this rectangular garden. They said they're going to create a rectangular garden. Okay, so here's my garden. And they said the dimensions of the garden that was given, 22 feet by 16 feet. So it's 22 by 16. Okay. Then they want to build a path that goes around this garden. It says that the path around will be 4 feet wide. So when I'm over here walking along the path, I know it's 4 feet wide. Over here, my path is 4 feet wide that I'm going to walk. Over here, it has to be 4 feet wide. And down here, it has to be 4 feet wide. So let's kind of draw this path. Right, so that's a path around the garden. Okay, so it says, how much edging material will they need? Okay, so how much edging material will they need? So in other words, we want to know what is the perimeter of your path. Okay, because this is the edging material around the path that they're going to need. All right, so if this is 22 feet for the garden, I have an extra 4 feet over here and an extra 4 feet over here. So what is the length of my path? The 22 plus another 4 is 26, plus another 4 is 30. So I know it's 30 feet this way. All right, if it's 16 feet for the garden here, but then I have an extra 4 and an extra 4, 16 plus 4 is 20, plus another 4 is 24. So to find the perimeter, you would take 30 plus 30 plus 24 plus 20.